Interval of increasing and decreasing. Determine the intervals of increasing and decreasing for the function y equals to x to the power of 1 over 3 times x plus 3 to the power of 2 over 3. Now the reason of taking up this question is to get used to radicals, and we'll do derivatives here to find increasing and decreasing, and we need to simplify the equation. Also learn the process of simplifying equations with negative radicals, correct? So that's the kind of important thing which we should be looking at when we are doing this kind of question, right? So let's find derivative of this function. When we say intervals of increasing and decreasing, then really what are we trying to figure out? We are trying to find derivative, that is y dash, and if y dash is greater than 0, that means increasing, correct? And if y dash is less than 0, that means decreasing. And how to find whether it is increasing or not decreasing? It is to find y dash equals to 0 or it does not exist. So these are the 2 points which we are looking for. And then we'll make a table of values and check on either interval whether it is positive or negative. If y dash is positive, then increasing, negative, decreasing. That, in short, is the process of doing it. Now, let's find the derivative of this function. So it is product rule, correct? So we have y dash equals to derivative of the first function, which is x to the power of 1 over 3, will be 1 over 3 x to the power of 1 over 3 minus 1 times the second function, which is x plus 3 to the power of 2 over 3 plus derivative of second function. So derivative of second function is 2 over 3 x plus 3 to the power of 2 over 3 minus 1 times first function, which is x to the power of 1 over 3. So we kind of get a complicated equation with all the radicals. So first step, let's solve these radicals. So we get 1 over 3 x to the power of 1 minus 3 will give me minus 2 over 3 times x plus 3 to the power of 2 over 3 plus 2 over 3 times x plus 3 to the power of, so when you do 2 minus 3 you get minus 1, so minus 1 over 3 times x to the power of 1 over 3. So we got all these radicals. Now, how to simplify this kind of equation? Out of these powers, which is the lowest, you have to check. So we have x to the power of something here and x to the power of something. Now what is common? This is what you have to check. Similarly, we have x plus 3 with some exponents, which is lower. Minus is lower, of course, right? So we'll factor these out. And in the numbers, 1 over 3, right? So 1 over 3 is common number. So let's factor out the common things, which is 1 over 3. And here, x to the power of minus 2 over 3. And this one, which is x plus 3 to the power of minus 1 over 3. So we factored out common things from both the terms. What are we left with? Here we have already taken care of the first two, and this one is left. So what do you get here? You get here x plus 3 to the power of 2 over 3 plus 1 over 3. So let me write here 2 over 3 plus, I should say minus of minus 1 over 3. Those two minus becomes plus. So that is how I get plus 1 over 3. Do you understand? Minus of minus. Now from here, what do I get? I've already taken 1 over 3, so I'm left with 2. And x plus 3 to the power of minus 1 over 3 I've taken out. So this one I'm left with x to the power of 1 over 3. So what I will do this time is I'll show you how I got plus here. Minus of whatever I factored out, minus 2 over 3. Do you understand? So that becomes plus. That is what I did here, right? Okay, so let's see what that is. So 1 over 3 x to the power of minus 2 over 3 times x plus 3 to the power of minus 1 over 3 times, let's do this math. So it is x plus 3 and the power is 2 plus 1 is 3. 3 over 3 is 1. So we are just left with x plus 3 here. Plus 2 times, now here what it is? 1 over 3 plus 2 over 3, which is 3 over 3, which is just 1. X to the power of 1 is x itself. correct? So we can now write this as, so it looks a lot of steps, right? But it's not that difficult. Now we are getting into closer. So what is the numerator? See, these terms are with negative exponents. They come in the denominator along with 3. Do you see that? This term comes in the numerator. It says x plus 2x, which is 3x, plus 3. Do you see that? X plus 2x plus 3. So we'll write 3x plus 3 here, okay? In the numerator, and the denominator is this 3, x to the power of 2 over 3, and x plus 3 to the power of 1 over 3. Do you see that? It is this simple. And now we can take 3 common and simplify it further. That's the beauty of this question. 1, because I'm 3 cancelled out, so I should write x, or should I do? Okay, so let me write x plus, let me factor 3 first. Okay, 3, and then I'll write x plus 1, and then I'll cancel. So we got 3 here, and x to the power of 2 over 3, and here I have x plus 3 to the power of 1 over 3, right? And now at this stage, I'll cancel 3 and 3, okay? Okay. So numerator has x plus 1. So that is the simplified form of the derivative of this. In itself, it is a huge question, right? For you as an exercise, once you learn the techniques, you need to sketch the graph of this function, right? At present, we will only check increasing and decreasing intervals. Well, by doing so, we actually figure out a lot about a graph. So, to find increasing and decreasing intervals, what are we interested in from this equation? First, when is it 0 and when it is not defined? These are the two things we are interested in. So, when is it 0? Let me write down when is it 0. It will be 0 when numerator is 0, correct? So, we get y dash, let me just figure out here. So y dash equals to 0 at x equals to minus 1, correct? Now when is y dash not defined, does not exist, that means denominator is 0. Denominator can be 0 at x equals to 0 or x equals to minus 3. Is that okay? Minus 3. So we get these points, x equals to 0 or x equals to minus 3. Right? So at these points, we have a kind of demarcation of our intervals. Now what we will try to do is analyze either side of interval along with these points, right? So let me just draw a number line kind of thing here. So here we have points of interest are minus 1, 0 and minus 3. So let's take these points like this. Correct? So I'll write here, this point for me is 0, the leftmost point, and then I have minus 1 and minus 3. So these are my points, and these points divide the whole plane in intervals, and this interval is from minus infinity to minus 3. This is from, I can write like this, minus 3 to 0, and this is from minus 1 to 0, sorry, minus 3 to minus 1, minus 1 to 0, and 0 to infinity. So these are my intervals, right? Now in these intervals, I will take test points. Now greater than 0, I can take test point as 1. Here I can take test point as 0.5 minus. Here I can take test point as minus 2. And in this interval, let me take minus 4 as my test point. Right? Now what factors do I have here? Now the factors for y dash here are x plus 1. So we'll give factors like these factors. X plus 3 to the power of 1 over 3. And then we have x. Let me take now x plus 1. I'm trying to take factors in this order. X plus 1. And the next factor is x to the power of 2 over 3. Correct? So these are my factors. Now I'm just drawing guiding lines so that things really don't mess up much. I have very limited space to work with. Let me push my page a bit. Now, if I put minus 4 here, then what do I get? I get a negative number, right? Cube root of negative numbers is possible. Let me also draw these lines so that I make perfect tables. Okay. So I get negative. If I put minus 2 plus 3 is positive, so I get positive here, and thereafter I will get positive values. In this case, if I put minus 4 negative, minus 2 negative, minus 0.5 will give me positive values. And in this case, if these are negative, x to the power of 2 over 3 will be what? Negative or positive? It's square, right? So here it is a cube root. So when you do cube root and then you square it, it becomes all positive, correct? So x to the power of 2 over 3 will be always positive. Is it okay? Because of that square thing in it, right? Now, what we do is we just multiply the three factors and see what do we get. Do we get negative or positive? Two negatives and a positive makes it positive. One negative, all positive, all positive. Do you see that? All positive. Now, positive means increasing, negative means decreasing. Positive means increasing, increasing. Do you see that? So we get our increasing and decreasing intervals right there. So which are the increasing intervals for us? These are the increasing intervals. So we got three increasing intervals, right? And one decreasing interval right there. Do you see that? So that is how you can get increasing and decreasing intervals for this kind of a function. I would like you to go through this process, understand the steps, and critically analyze these steps so that you understand how to simplify radicals. And then this part you know, right? And then write down your answer very clearly. That is, increasing intervals are, what I will do is, since I'm always running out of space, I'll just put those answers right there, right? Increasing intervals and the decreasing intervals, correct? So for me, a lot of increasing intervals. So increasing intervals for me are minus infinity to minus 3, and then from minus 1 to 0, and then from 0 to infinity. Now, it is important to understand that we are not writing those critical points where the derivative is undefined, correct? The derivative is undefined, that means it is approaching infinity in those cases, right? Now, reason for that undefined derivative is actually a cusp. So these undefined derivatives are because of the cusp, right? Think about it like that. And let me just share with you how the graph of this function look like so that you can appreciate it, right? So it's not a part of this exercise, but I'm trying to share with you how the graph will look like. So we have a cusp here at 3 actually. And at this point, we have like this. Increasing, increasing. Do you understand? So there's a point of inflection here. No maximum, no minimum. But at this point, we have a value which is minimum, which is this value. Do you understand? And here we have a maximum, and that is our maximum at minus 3. So that is how our graph is going to look like. So this is your point minus 3, and this is at minus 1, and that's your 0, right? So that is how your function is, and it does have a minimum value here and a maximum here. So when you learn all the techniques, you have to move forward doing the second derivative to get the details and sketch the graph. You should expect this kind of an answer here, right? Okay, anyway, let me complete my answer. So those are the intervals of increasing which I have just put for you. And decreasing interval is from minus 3 to minus 1, right? So this is decreasing. Correct. So that is how we are going to solve this question. Have a good look at it. Try to understand. It is a test problem, and in test you normally get this problem to sketch the whole function. So it takes quite a bit of time and thinking to solve this question. I hope you really like it. So share your opinion and share with your friends. Thank you and all the best.